In this tutorial, we will learn the basics of meshing in SOLIDO. We will learn advanced meshing functions later in the Meshing Part 2 tutorial. Corresponding exercise files related to this tutorial can be downloaded from the link mentioned in the comments below. Setting the calculation mesh in SOLIDO happens in 3 steps. First, the object is triangulated. After that, the triangulated object is rasterized to the user-defined grid. Lastly, the rasterized object is fitted to the triangulated object. We will understand this concept with an example of a simple sphere. As a first step, when we click on Fill, the wireframe geometry is filled with the material and triangulated as per the defined mesh size in the blocks window. This is what we call a triangulated object using the Fill Blocks tool. The second step is to rasterize the object, which transforms the object into a rectangular shape. Here we need to understand the difference between a grid mesh and a triangulation mesh. The triangulated mesh is generated using the Fill Object tool. Grid mesh, on the other hand, is defined in the grid window to develop a 3D voxel space. This is like a pixeled canvas in 3 dimensions. Rasterize checks if there is a triangulated object at the center of each voxel. If yes, then it fills that entire voxel where it detects material. At this point, using rasterize, we are converting the object into rectangular blocks. Now, the rasterized object can be exported from SOLIDO into Trisco if needed. You can understand that the finer the grid mesh, the higher the resolution of rasterized object will be. Finally, the third step is to create a fitted object. Here the core of the geometry remains in a rectangular voxel framework, but on the surface level, we link it to the original geometry mesh. This creates a smooth hexahedron at the surface level by either adding or subtracting the rasterized geometry. In the previous example, the grid was coarse and not refined enough to incorporate the sloped elements or to run the analysis. We shall test the output with this grid. We click on Fill Blocks to get the triangulated mesh. The next step would be to rasterize. Here the voxel generated by the coarse grid wouldn't incorporate the inclined shape of the plate. If we click on Rasterize, we see that the inclined geometry is eliminated because of the big voxel size. This is of course not the result we expected. We can locally refine and add extra grids for the parts of the inclined elements or choose to generate an automatic grid. From the Grids menu, choose Auto Grid Generation. The inputs for Auto Grid Generation can be entered as shown here. We shall understand each of these parameters in the next tutorials. Upon clicking OK, you notice a detailed grid. You can see on the sloped surface, the grid is more refined. Next, click on Fill Blocks to triangulate the mesh, then click on Rasterize. We now incorporate the sloped geometry after rasterization. Using Ctrl and H, you hide the selection preview and can visualize the object clearly. The object can be exported at this stage to Trisco if needed by saving as and selecting the extension .trc. It's important to turn on the selection preview using Ctrl and H, as it creates difficulty without the selection preview. Click on the fitted object, and the pixelated edge of the sloped plate is smoothened to fit the original geometry shape. Now we have the system prepared for the calculation, and we can click on Calculate to run the analysis. It's not mandatory to go through these 3 steps: fill blocks, rasterize and fit object manually. If you click on Calculate, SOLIDO automatically goes through these 3 steps to run the calculation. However, if you do these steps manually, you can visualize the output after each step and make any rectifications if necessary. You can visualize the geometry using various view styles, such as Show Boundary Conditions, Show Transparent and Materials. Lastly, choose Show Temperature to visualize the temperature gradient. You can clip any color from the Edit menu by choosing Clip Color. For insulation, color 133, toggle Show to No. Then you can visualize the temperature gradient without insulation. Turn on the insulation again, by toggling from No to Yes. Now, from the Edit menu, choose Clip Objects. It's important to note that we need to be in the rasterized mode or fit grid mode to clip objects. This is because the object must be linked to the grid's windows to perform this operation. At the grid's window, you can notice the maximum extent of the geometry in each of the x, y, and z axes. Say we want to clip the object at 45, you notice the temperature gradient through the cross-section. Thank you for watching, see you in the next tutorial.